Welcome to LinkedList 101. Linked list is a linear sequence of nodes. Unlike arrays, they are not stored in consecutive memory locations, so they do not have indexes. Instead, each element or node points to the next one. That means you cannot simply retrieve an element at a specific index. You would have to iterate through an entire list until you find the node you are looking for. Despite having that drawback, linked list do have a lot of advantages. For example, it doesn't waste your memory. Typically in the array, you have a fixed capacity of elements, and sometimes you are not utilizing all of its potential, which makes the memory go to waste. Linked lists, on the other hand, are memory efficient since their size changes at runtime. Another advantage of linked lists is their insertion and deletion operations. If you want to insert or delete the head element of your linked list, it will only take big O of 1 time complexity. Arrays, however, will take big O of n time complexity, as they would have to shift n elements for that operation. There are multiple types of linked lists. A single linked list, which is the most common one, is where each node is connected to the next one. Doubly linked list. Each node is connected to the next and to the previous node. And circular linked list, where the last element is connected to the first element, which makes a circle. To create a linked list, you need to create a class with generics. Every linked list has to contain a node that is going to store some valuable data in a reference to the next node. You can create a node by passing data to the constructor and setting the next value to null. For the linked list, you need to create the head element, which will be the first node in the list. You also need to keep track of the number of nodes in the list, so you need to add a new integer called length. Create a constructor where you initiate head as null and length as 0. You can overload your constructor by passing in various arguments. In order to add an element to the beginning of the list, you would need to create a method for this class. The method accepts data that needs to be stored. Note that the end user only passes on the data to your functions. He does not and should not have any control of your nodes. So we instantiate a new node for the data, and we assign head to the new node element. Also, we would need to increase the length property of this list. What if you want to add an element to the end of the list? Then you would have to iterate through an entire list. There is two possible scenarios here. One, list is empty, then you simply set head element to the new node. If the list is not empty, we create a current node, keep iterating through the current node while it has a next element. If it doesn't have the next element, that would mean that this is the last element of the list, so we can point this last element to the newly added node. And of course, we need to increment our list length. Now, if you're planning to add elements to the end of your linked list quite often, this might not be the best option for you. What you can do is to also keep track of the last element of the list, which we can call tail. Now that we know the last element of the list, we don't have to iterate to reach it. We can simply set tails next to the newly added node and set the new tail as the new node. This way we reduce our time complexity from big O of n to big O of 1. Thanks for watching. Please like this video and consider subscribing to my channel. I heard a lot of great things about it and I think you're gonna enjoy it. You can go to the next video now.